Okay, so good afternoon. Our aim for today is how do we evaluate compositions of trigonometric inverses. At this point, you can start typing in your responses to the do know in the chat. So part A is arc cosine of 0, part B arc cosine of negative root 3 over 2, and then part C is arc sine of root 2 over 2. Okay, so again, feel free to type your answers in the chat for this. Okay, so we got pi over 2, 5 pi over 6, and pi over 4 from Dorothea. Anyone confirm, or you can also disagree with that? If you confirm, just say confirm in the chat. Okay, so no one has anything to say. Okay, all right, so we got three confirmations. Okay, thank you for that. Yeah, so I'll scroll up to the answer. It is, in fact, yes, pi over 2, 5 pi over 6, and pi over 4. So in degrees, that will be 90 degrees for pi over 2, 150 degrees for 5 pi over 6, and then 45 degrees for pi over 4. Okay, that'll be answers for the do know. Okay, I'll give you a sec to copy that down, and then from there we'll move on to the examples for today. All right, anyone still need this? You can speak up or type in the chat. No? Okay, gonna move on then. Okay, so the question for today is a very specific type of question that has to do with trig inverses. Now, the applicability of this problem, it will come up next year in calculus. So when you do something called an integral in the second half of calculus, you're going to come up with situations where you're going to have this type of expression, as you see here in the example, like cosine of arc sine of 3/5. So that's going to come up again next year in calculus, the second half specifically when you take integrals of functions. Okay. So with that being said, let me show you how to work through this problem. First thing we're going to do is substitute. So we're going to let theta equal arc sine of 3/5, right? So the output to any arc trig function, like arc sine, arc cosine, is going to be an angle, right? So as we saw in the do now, right, we got three different angles for the answers, right? Same thing here. So arc sine of 3/5 is going to be some angle, right? We don't know what it is, but we'll just leave that as a placeholder. So we're going to let theta equal arc sine of 3/5. And then from there, you're going to take the sine of both sides. Okay, so actually, I'll write that actually. And take the sine of both sides. And that'll lead us to the next step, which is sine theta equals sine of arc sine of 3/5. Now, the left hand is going to say the same in the next step, but sine of arc sine is just 3/5, right? So because they're inverse functions, if you compose two inverse functions, you're going to get the independent variable, or the x coordinate, like 3/5 in this case. So the equation will become sine theta equals 3/5. Okay, and then at this point, just remember that sine theta is defined to be the ratio between the opposite and the hypotenuse side in a right triangle, and we know that that's equal to 3/5, right, according to this equation. At this point, you're going to draw a right triangle. Okay, so as you can see from the diagram here, so I drew a right triangle, angle theta, and then the opposite side is 3, hypotenuse is 5. And the remaining side, therefore, is going to be 4. You can use the Pythagorean theorem, or if you just remember that there's a Pythagorean triplet, like 3, 4, 5, right? But regardless, the remaining side is 4. And then at this point, you're going to substitute back. Okay, so like cosine of the original expression, like the original expression was cosine of arc sine of 3/5, right? But if we replace arc sine of 3/5 with this substitution of theta, then all we're really solving for is cosine theta. Okay, So cosine theta is, just remember, it's the ratio between the adjacent hypotenuse in a right triangle. And in this case, it's going to be 4/5. Okay, so overall, our final answer is going to be 4/5 for this question. Okay. All right, so if you're initially confused, that's okay. I know, there's a lot to take in, a lot of new different, steps that we have to take to solve this question. But, as you'll see, when we solve more of these questions, they're all the same. You just let theta equal the inside function, take the sine, cosine, or tangent, or whatever of both sides, and then from there, construct the right triangle, and then solve for the original value. Okay, so substitute, take the trig function of both sides, right triangle, and then value. Okay, does anyone still need to copy this down? You can speak up here or type in the chat. Okay, so yeah, I'll give you another minute. Just let me know when you're done. Okay. Well, actually, if you're done copying this, feel free to just start the classwork. So the worksheet is on Google Classroom. Yeah, that's all we're going to do for the rest of the class. We're just going to practice these questions. So the first question was tan of arcsine of 1/5. Okay, so you can start by solving that. But yeah, if you still need to copy this example, that's fine. I got a question from Sonia. Wait, can we just do arcsine in our calculator and then do the cosine of that? Yeah, well, yeah, if that works, yeah, that's fine. But as you'll see in some other examples, like question 3 on the worksheet today, you're going to see that you're going to have like variables. So like instead of 3/5, you're going to have like x, right? So in that case, you have to actually solve using this method. And that'll come up in calculus also. Like you might not have like numbers, you might just have like variable expressions. Yeah, but calculator, good way to check. But yeah, please do practice using this method. Okay, if no one else needs the example, I'll just move on to the worksheet. So I'll just show you the worksheet. Yeah, again, it's also on Google Classroom. So just take the next, say, 5 minutes or so, try to solve the first 3 questions, and then we'll reconvene about these solutions. Okay, so let me pause you here. Let me go over the first question, just in case, I just want to make sure that you're doing it correctly. So let me show you the answer. All right, here's the answer. It's the final answer was root 6 over 12 if you rationalize. Did anyone feel comfortable explaining this? Like, just walk us through this solution here. If you do, you can speak up right now.
I can go. So basically, you know that sine of theta equals opposite over hypotenuse. So you choose an angle in your triangle to be theta. So in this case, we chose the bottom right angle. So we know that the side opposite is 1 and the hypotenuse is 5. And then we plug that into the Pythagorean theorem, which is a squared plus b squared equals c squared. And we have 1 squared plus b squared equals 5 squared. We just simplify that and we get, square root of 24, simplifies that square root. And then since tangent is opposite over adjacent, we already know the opposite. Now we know the adjacent is 2 over radical 6. So it's just 1 over 2 radical 6. And then you simplify that into radical 6 over 12 because you can't have a radical in the denominator.
All right, very nice. Thank you for that. Any questions about this question? No? Okay. All right. Thanks again, Max, for the explanation. We'll go to question 2 now. The final answer was 8 root 73 over 73. Very similar to question 1. Anyone for this one? All right, let me call on someone random. All right, let's go to Colin. Do you feel comfortable explaining this?
No, I don't. I'm not.
No? Okay, that's okay. What about you, Rachel?
I think so. So because it's tan, it's opposite over adjacent. So the two sides are 3 and 8. So then when you add both of those squared and then take the square root of that, you get square root of 73. So the cosine of that angle would just be 8 over radical 73, and then you multiply it, and yeah.
All right. Well, the last step, let's say rationalize. So we're going to rationalize the denominator. Yeah. Okay. So, but yes, very nice. Yeah. Yeah. Just tangent, right? Opposite over adjacent. Solve for the hypotenuse, which is root 73, and then we need to solve for cosine now. So that'll be adjacent over hypotenuse. Yeah, I can upload these. I'll upload the lesson plan every day. So yeah, it's on the lesson plan. Yeah. Let me go over question 3 now. So question 3 here, it's different because we have, instead of a number, we have a variable, just x. So we're gonna do the same thing though. Like it'll be theta equals arc cosine of x. Take the cosine of both sides. We get cosine theta equals x, which I rewrite as x over 1 because I want to see it as a ratio, right? So cosine is adjacent over hypotenuse, and then from there, you can draw your right triangle, right? We have theta. Adjacent is x, hypotenuse is 1, and then for the remaining side, I label that as b. Just that's what they normally use in the textbook, so I just followed suit with that. Use the Pythagorean theorem to solve for the missing side in terms of the other two sides. So we get x squared plus b squared equals 1 squared, right? Pythagorean theorem, and then subtract x squared from both sides, you get b squared equals 1 minus x squared. Take the square root of that, you get plus or minus square root of 1 minus x squared, but we're going to take the positive value because, we're talking about the length of a side here. So therefore, we have to take the positive value, right? It wouldn't make sense to have like a negative length. And then from there, we need to solve for sine, right? So sine theta, that would be opposite over hypotenuse. So opposite is b, which is the side we solve for, and then hypotenuse is 1. Okay, so your final answer is square root of 1 minus x squared over 1, which you can just write that as square root of 1 minus x squared. Yeah, that'll be your answer. That. All right, so that's your answer for question 3. I'm gonna skip. Well, actually, let me ask you. Did anyone still need the solutions here for 2 and 3? Gonna speak up here. No. Okay. But yeah, I'm gonna post these solutions anyway if you need them. Okay. So, but let me get to question 6 now. I'm gonna skip 4 and 5 because they're similar to what we've seen earlier. 6 is different because we're actually going to end up using a double angle formula. So we have sine of 2 arc cosine x. Okay, we're going to start with the same thing. So we're going to let theta equal the inside function, which is arc cosine of x. And then you take the cosine of both sides, you get cosine theta equals just x, right? Or that'll translate to cosine theta equals x over 1. From there, you draw your right triangle. So cosine is adjacent over hypotenuse, so that would be x, and then 1 here. And then the missing side is b, right? So this is just like the question we just solved for, like question 3. We're going to solve for the opposite side. We're going to do the same thing. We get square root of 1 minus x squared. And then at this point, if you evaluate the original function, or the original expression, I should say, we get sine of 2 theta, okay? Because, we let theta equal arc cosine x. So we're going to get sine 2 theta. And if you remember, right, we can use the double angle formula to solve for that. Sine 2 theta equals 2 sine theta cosine theta. And as another reminder, right, we use the angle addition formula to derive this formula, right? So anyhow, it's 2 sine theta cosine theta. Sine theta is opposite over hypotenuse, so that's opposite, which is square root of 1 minus x squared. Hypotenuse is 1, right? And then cosine theta we know is already x over 1, but you can, just do adjacent hypotenuse is x over 1. But all in all, the final answer is going to end up being 2x times the square root of 1 minus x squared. Okay. But yeah, that's the most difficult these questions can become. They might like throw in a double angle formula, but yeah, it's always the same. You substitute for an angle, right, and then draw the right triangle and then solve. I'll give you a sec to copy this.
Afterwards, would you mind like scrolling up after we're done copying this?
Yeah. Did you need question 3 or 2 or 1?
Yeah, 3 and 2 and 3.
Okay.
Just to review.
Yeah, I will. Okay. But yeah, let me just or tell me if, well, yeah, I'm assuming that you guys are still copying, so yeah, just tell me when you're done. Okay. Did anyone still need question 6? No? Okay, I'm gonna move up then for questions 2 and 3. Well, if you want to check 4 and 5, the 5 was square root of 1 minus x squared over x. And then question 4 was 12 over 13. Okay, but and I'll post the solution set on Google Classroom. And here is questions 2 and 3, in case you need it. Okay. But yeah, in closing, let me just say that, yeah, there's SGI at 2:47 today in case you have questions. Other announcements, our next quiz will likely be next Friday. Okay, so that market period ends next Friday, the 11th, I believe it is. But yeah, so we'll have our fourth quiz next Friday. And also as a plug for quiz 3, make sure, if you haven't yet already, to post a comment on Google Classroom in case you want me to grade your work for partial credit. Most of you have already done this, but yeah, some of you haven't. So please do that if you haven't yet already. Okay. All right, but that's all I want to say for today. I'll see you all tomorrow. Have a great day and take care.